Thank you so much for the introduction, Barbara. Now I'm here to introduce you to blockchain, cryptocurrency, and decentralized finance. What the purpose of this presentation is to give you a primer. That's what the title said. So the idea is I give you very brief explanations of some of these major concepts here. I will talk to you about what a cryptocurrency is, what a blockchain is, and how it all can be used for a new area, which is referred to as decentralized finance. In a nutshell, really what this is about building a new financial infrastructure for the 21st century that is open to all and can be used by all. Now, I also want to do a bit of an outlook. I want to talk about some of the risks that are involved, and then I want to talk about what other developments we see that also relate to this area. At the very end, I want to describe a little bit about the resources that we have here at UofT and what we have done in this area, what research is going on, teaching, and so on and so forth, and how you might be able to contribute to this. So let's get right into it. Let me first talk about what a cryptocurrency is. In my opinion, there is way too much attention being paid to Bitcoin these days, and it's very difficult to talk about cryptocurrency without talking about Bitcoin. The media in particular is mesmerized by the volatility of the price. It went up from 8,000 last year to about 60,000 earlier this year in US dollars, and now back to 35,000. Now, obviously, this is very fascinating, but it is a bit of a distraction because, cryptocurrencies and blockchain are about a lot more. And in some sense, even though I'm giving you a primer here, it's sometimes a bit difficult to understand really what it is. What is, however, relatively easy to understand is how it can be used. Now, the first thing I should say is in 2017, Jamie Dimon, CEO of JP Morgan, one of the biggest banks in the world, came out and said that Bitcoin is a fraud and that he would fire anybody who would be trading Bitcoin in his firm because they would be stupid. Now, Bitcoin at its core is code, right? It's not a thing. I like to liken it to digital stickers. But at the core, it's just a piece of code that a large group of people have agreed to use in a particular way. So how could this be a fraud? Right? That makes no sense by itself. It's also not a Ponzi scheme, as Nicholas Taleb said, who wrote The Black Swan. It is just a piece of code. Now, but the core feature of Bitcoin is you have digital items that you can exchange. And the Bitcoin network is effectively only doing this one thing, or as I like to call it, it's a one-trick pony. But if you think about it a little harder, what we really see in this network is that a group of people agrees to deploy a particular code and that they agree when that code is run. And that at its core was the idea that Vitalik Buterin had when he looked at this more carefully and said, well, can we not, instead of running this particular piece of code, can we not build a network around the idea that we can run any piece of code? And that basically gave rise to the Ethereum network. Now, in the Ethereum network, essentially, it's a network of computers. So it's not one, but it's a distribution of computers. And effectively, it's like a big database where changes to the database in some form of code, and the database is very general in the sense of, it could be pieces of code that could be run, where the entire network agrees on changes on code. Now, so the idea is that somebody makes a request to run a piece of code, and then all the computers in this network run the same piece of code, so that the state of the network itself is changed according to this particular piece of code. Now, what is the problem with that? When you run a piece of code and you ask a large network of computers to run a piece of code, you can easily write a piece of code which would basically run infinitely long, right? And would never stop. And if you do that, you could crash that code, right? So now, how do you get around that problem? Well, the person who wants to ask to have the piece of code run, you make them pay for it. So every time they want to have a piece of code run, they give a particular amount of money, and that amount of money pays for the running of computational cycles. And when that money is exhausted, the code stops running. And that, in its effect, is what a cryptocurrency is. It's the means of payment that you have in order to run these pieces of code. So it's an internal accounting mechanism, and it is actually essential to the operation of the network. But here's the economic functionality that is critical to it. The cryptocurrency is something that you use to get a utility, right? So to get a service. So, and this is slightly why, for instance, the cryptocurrency Ether is different from Bitcoin. In Bitcoin, I mean, you get the one service, which is the transfer of a piece of Bitcoin. In Ethereum, you use this item to pay for the service, which is the computation. And people are willing to pay quite a bit. So about $7.5 million each day is paid in fees in the Ethereum network. So that's about a healthy $2.5 billion a year that is accumulates in fees. And it gives you maybe some idea of why this network as a whole actually can legitimately have money if people legitimately want a piece of code to run on the network. All right. Now this is, I understand this is very abstract, but now let me crank it up just a notch more, which is, let me explain to you what a blockchain is. Now, the initial invention of Bitcoin by Satoshi Nakamoto was effectively him putting together two existing pieces of technology. The two pieces of technology were basically the idea of a blockchain, which is used in timestamp servers, and the proof of work protocol. Now, I don't want to go into the details of the proof of work protocol, but I'm going to explain to you why this is useful and why it's actually important to have. Bitcoin, by the way, was not the first attempt at doing electronic cash, but the problem with most electronic cash is that they couldn't solve the double spend problem, and Bitcoin has solved that. So now, what am I talking about here? Effectively, as I said, a blockchain is just a big database. There's transactions or running of pieces of code that happen. So all of these transactions are bundled together. This is the convention, and processed in blocks, in pieces of code. Now, a block has a header and a footer, and I hope the ones that are experts on this bear with me for a second. It's not entirely accurate, but it gets you to the idea. But it has a header and a footer, and now when you have a new block, the trick about the header and the footer is as follows. Think of the footer as a digest of all the information in the block. Essentially, it takes all the data that's there and puts it into a particular 64-bit piece of information. It's called a hash. And this way to generate this hash or this digest is unique. So it's basically a function. And so then what you do is when you build the header of the new block, you add the footer of the preceding block so that each block links to the block before. Now, why is this useful? Well, if you wanted to make a change, for instance, sometime in the past by manipulating a record, what would happen is that the digest is no longer accurate. And then the network would notice that the digest of this change block is not the same as what was referenced in the block that follows it in the header, and therefore the network would reject this manipulation. And so you can't do that. Now, that makes the blockchain, that makes actually the past unchangeable, and it makes it suitable as a vehicle to look at value transfers. But there is a little more to it. Now imagine you have a transaction here in this blockchain in the second block from the left. Right? And so this is, for instance, Alice gives Bob money, and Bob in return gives Alice a car. Now the car transfer happens in the real world. Now, as I already said, Alice cannot revoke this transaction on this blockchain because that would be rejected by the network. But what Alice could do is she could build a new blockchain which eliminates or ignores the particular block and which creates essentially an alternative reality of the new blocks. Now, how would she do this? Well, she would have to have the ability to build a large number of blocks, which basically are, as a longer chain than the existing chain. And there's a convention that you usually add a new block to the existing longest chain. I'm not going to go into the details there. Now, how could she do this though? Well, she needs to be able to predictably create these blocks in a row. And here's how the competitiveness and, if you want, the economics of blockchain come into place. So here what happens is that many entities want to compete to build these blocks. Why? Well, because they get paid for doing so. So now what you need, therefore, is you need a mechanism that determines at random who will be the next entity that gets to form a block. Because if you do have a random mechanism, then here Alice, for instance, would not have the certainty that she needs in order to create a series of blocks. And that's essentially what the proof of work protocol does. It is a mechanism which helps you to select among a very large group of entities that want to contribute and build the blockchain, one at random that creates a new block. This is not the only mechanism that exists, but this is the key idea behind it. So if you put these two items together, you can solve the double spending problem, and you can build an internet of value where you can have value transfers, and of course where you can have the decentralized execution of code, which is essential for what's coming next. Now I gotta be honest, understanding Bitcoin and blockchain is actually not straightforward, and it is, as you hopefully may have seen now, is not that straightforward to explain, because it is a rather abstract concept, but the application is not. The application is actually really exciting, because what it is at its core is it allows value transfers, right? Decentralized value transfers without the involvement of a trusted third party. And therefore, the direct application of such a thing would be the area of finance. And what we've seen over the last year or so unfold is the coming live of a large number of projects which have the capacity to fundamentally transform the way how finance works in our modern world. So let me give you this a little bit of an explanation here. So what is decentralized finance? It is the provision of financial services without the necessary involvement of a traditional financial intermediary. So in other words, you provide finance such as it is, the same level of access to credit and loans and so on, but without involving a bank or a broker. Now, why is this important? Well, here's a little graph that shows you the prices for financial services for the last, 20 years or so. And as you can see, this is for France, Germany, and the US. It's data from the BIS. The prices for financial services have gone up, right? In France, at least they have stayed constant. In France, they stayed constant. In the US, they went up by about 30%. Okay, and so then if you think about finance and you see, well, finance has transformed since then, right? So much of what finance did became digital or became electronic. So computer technology was a major contributing factor to the transformation and to what finance has been doing. And if you look at the cost of IT services, they have gone down quite dramatically. In the US by about 90%, in France and Germany by something like 30 to 40%. So in other words, one of the major inputs into a technology has gone down, and yet the price of what came out, the service itself, has gone up. That is, for an economist, a little concerning, and you have to ask yourself the question of how this is possible. Now, here's my take on this one. I believe that the fundamental problem with the financial industry is its infrastructure, because it is effectively siloed. Here, for instance, you have the payments network, you have a network which stores bonds, stocks, options, you have swaps, another network which deals with swaps, credit default swaps, mortgage-backed securities, collateralized debt obligations, and you have insurance contracts. All of them run on different networks. And to link them, you need the financial institutions. Now, why is this problematic? Well, it makes it problematic because financial institutions become gatekeepers. And the role of a gatekeeper can be a useful one, but it can also lead to what's referred to as rent extraction, when you get money not for what you do, but for what you are. When that happens, you create economic losses in an economy. And I think we're pretty close to that, the case. I'd be very happy to discuss that in more detail, especially for the case of Canada. Now, what is a blockchain and what is decentralized finance? Well, in practice, what the idea of the provision of financial services without intermediaries boils down to is that you create a new financial infrastructure that is a common resource that anybody can operate on. And when I say anybody, it's not just financial institutions, but anybody who has an idea to bring people together to provide essential service or product can use this resource to deliver it. This has been an area of enormous growth. You can see in this graph here, it's essentially exponential growth. I used this graph or version of this graph in October when I taught my class, and you can see, the increase that was there from essentially zero to $12 billion at the time. It went almost up all the way to 90 billion over a very, very short stretch of time. So there's tremendous growth in this area. And this is actually what I think also the media should be spending more time on. Now let me give you a few examples to just illustrate to you why this idea of a common resource is useful. And the first thing I should talk about is decentralized trading. Because a lot of what the decentralized finance world is about is you transfer values of value, transferring items of value involves some form of trading. Right? Now, one of the most ironic things about the blockchain world in its early days was that even though these cryptocurrencies lived on decentralized network, and the whole ethos of this area was all about decentralization, the trading of these digital items still occurred on centralized exchanges, like somebody having a laptop or a server somewhere, and nothing of that happened on the decentralized network, and that leads to fraud, hacks, and so on and so forth. We had our own little example here in Canada with Cryptocurrencies X, but that's just So this is really just not the way how blockchain intends to be. But organizing decentralized trading is not easy. Now, conceptually, it's not that hard because, ultimately a limit order, which is a price order to say I want to sell 100 shares of RBC for a particular price, is just a smart contract. It's a piece of code that I can deploy on the blockchain. And the first implementation of decentralized trading were exactly that. So you basically would submit a smart contract, which is an order, you send it to the blockchain, and then anybody could trade against it, and there were then websites that would collect that information to build order books. But that's not a very efficient way to do it, and it's actually pretty expensive, because you have to, every time you put in an order, you actually have to pay for it. So that's not the way it should be done, and it's also not very innovative. But then some people came up with the idea and said, hey, why don't we actually use some features of a blockchain, which is that you can build a contract which is essentially a vault or a collection of a pooling contract where people can pool resources and do something. And so the idea there was you build a contract where willing liquidity providers deposit funds so that other people can trade against it. Now, the interesting part about this is you deposit it into this contract so that you get a pool of liquidity. And as somebody who has contributed to that pool, you can retain the exposure to the asset that you want, but for providing liquidity, you actually receive a fee, right? So in other words, you actually make your capital work. So the way this works is you pool the resources. Somebody can send money to this contract and then in return receives an item from this contract. All of this would happen instantaneously. That means somebody wants to make that trade. This is a so-called atomic swap, where on the blockchain, this contract initiates an exchange of DAI, so one item to another item, which happens directly. No 2-day delay, and so on and so forth. It is a phenomenal idea, and it works extremely quickly. Now, as you can see here, the growth in the volume that is processed by these decentralized trading since they've gone live sometime in the middle of last year has been phenomenal. Nowadays, these contracts collectively process more trades than, for instance, Coinbase, which is at IPO was valued at $80 billion, right? So this is this is a phenomenal increase. And the really cool part about this is this core contract is about only 200 lines of code. So if you want to, you can say that 200 lines of code functionally replace the function of an $80 to $100 billion company. Now, next thing is decentralized lending works in a similar principle. You take an asset of value. For instance, it could be, cryptocurrency like Ether, but it could also be a non-fungible token, which is a representation of a painting. And in the future, you can use anything that can be tokenized, so where you can store a token on the blockchain can be used as collateral. And then the collateral locks this up, and in return provides you with funds that you can use in order to, here this is a digital representation of the US dollar, it's called DAI, and you can use this for purchases or for other investments if you want. And so these applications are out there and they're already working. Now, this is often linked to or described as DeFi Legos, meaning that there is a large number of applications that you can combine together in order to create a product for yourself, in order to create an investment portfolio for yourself, or just to use it simply, to make purchases with digital representation of items. Now, let me explain to you also how these interact. And one of the coolest features of that is in this world is what's referred to as a flash loan. What a flash loan is essentially is you borrow something and you repay it essentially at the end of a string of transactions that happen all at the same time. And so this loan at itself is an entirely risk-free loan. But it is crucial for the operation of the system because effectively it ensures that the forces of arbitrage are at work so that markets work efficiently. So let me give you this as an example. Imagine you have made a collateralized loan in a system called Compound, and the borrowing rate that you currently pay for that is 15%, right? And so, for this example, which I took from Cam Harvey's upcoming book, is you deposited $150 ethers, which are worth, let's say, 10,000 DAI, which is the digital representation of a dollar. Okay, so now, but you observe that on Aave, which is another system, you can actually borrow at 5%. So what do? Well, you initiate a flash loan. So you go to Aave and say, I want to have a $10,000 flash loan. Then you take these 10,000 DAI and you repay it for your Compound loan. Then you go to the Compound contract that you have and you reclaim your collateral. Then in the fourth step, you take your collateral and you form a collateral, and now you deposit it into an Aave contract. Then you take 10,000 DAI from that contract, right? So that the ones that you received in return for your collateral, and you use that to repay your flash loan. And the way this works is this is all a string of transactions which are submitted simultaneously. And if any of these different steps would fail, then automatically all of these transactions would fail, and therefore the loan never comes into being. And so this makes the loan effectively risk-free. Now, this is a very simple example. You can have these loans and these strings of transactions. They can span 150 different types of transactions. But what this really means fundamentally is that because all of these items and because all of these contracts work on the same infrastructure, the forces of arbitrage are really strong, and so therefore as a market this is by far more efficient. And again, the contracts that are involved in the codes that are run, they're relatively short, just a few dozen lines of code to make this work. So this is a phenomenal development in the world of finance. Now, obviously this is something that I'm very excited about, but I think it's also important to emphasize that there's some risks and that there's open problems. I'm just going to go briefly over this. Many of these apps are still very experimental, so some of the problems in which the way they function, we still find out now. There are kinks that need to be ironed out, and there's a phenomenal amount of redevelopment over and over again. There's also some real progress in the underlying technology needed. For instance, the way the blockchains work. The Ethereum network, for instance, still runs on a proof of work protocol, which we know is energy inefficient. Now they're already running a parallel chain which is based on proof of stake, which would essentially eliminate 99% of the energy usage of the blockchain, and they will be merging them by the end of the year. But there are still steps that are necessary in order to improve the scaling of these blockchains, because they can't process very much at this point in time. I'm going to talk about some of the work a colleague of mine is doing on this a little later. So there are still some problems that need to be ironed out before this is really ready for the big stage, if you want. More importantly, though, even with all of the tech problems out of the way, there are some fundamental problems that change the way how we think about risk in this world. Now, usually we have accountants, for instance, and auditors that look at firms to make sure that funds are being used properly. And so they basically are able to look under the hood. But when you have these smart contracts, they are out in the open because everything is open source, right? But there is a separate set of problems that could arise. So for instance, there could be a smart contract could be deployed and the code is not written well. So that happened, for instance, in the very first iteration of a blockchain with the DAO, just a year after Ethereum launched, where 2 lines of code in a major contract were in the wrong order, and that allowed somebody to essentially extract 30% of the entire amount that was deposited in this contract. You need to get rid of that, of course. Now there's firms that actually already provide the service. Here in Toronto is one called QuantStamp, and they're working on this. But it's really important to understand that once you have written a contract, it is out there and it can be used, right? Everybody has access to it, and if it runs the wrong way, it's very difficult to get it to what is it called, to bring the horses back into the barn. Next thing is, even when you have written the contract, and even if the code has no problems or no vulnerabilities, it's still not clear that the economic incentives that it tries to provide actually work the way how you intend them to work, right? So you actually need to think this through very hard, and that requires business people to think about, and economists to think about these problems, and to actually understand what the environment is and how they would be used. There's also, when you write a contract, you may have to think about foreseeing the unforeseen contract contingencies that are important for you, and you could have contagion risks, right? So when one contract gets liquidated, another contracts may have to get liquidated, and so on and so forth. But differently, for instance, to like the LTCM crisis in 1999, where basically one hedge fund almost blew up all of Wall Street through a possible snowball effect. In this world, it's transparent what happens. So what you need is just to do proper data analytics of the existing contracts and how they work. So it requires a different type of thinking, and it requires using the information that's out there in the open. Another problem that needs to be solved, and this is speaking from an economics perspective, is we will build institutions that run on these blockchains, and they run therefore based on code, but they still have to make decisions, so they still have to be governed in some way. So how do you govern them correctly? How do you govern these decentralized organizations? How do you write the code in such a way that you actually have a working decision-making process? We know how to do this with boards and people, or well, we have at least an idea about it, but doing this with code is actually a completely different problem. And of course, there's the role of regulators, right? So now one of the things is, these are not banks, these are not institutions, there's not a firm that you can go to and knock on the door and say, hey, you have to do X, Y, Z, right? That's not the way it works. You can write a code, any kid in the world can write a code and deploy it. So you can't go necessarily, first of all, the kid may not be in your jurisdiction. Second, you may not know who the kid is that actually deployed the code. And third, the code is going to be out there. As long as the blockchain lives, that code continues to exist. So how do you handle this as a regulator? I think it requires a rethink. It also requires a rethink, I think, for law enforcement, because law enforcement made financial institutions essentially a deputy for their money laundering or for the prevention of crime. Now, this is an open network where this is not possible. So on the other hand, of course, law enforcement has a much higher degree of transparency. So I think they have to rethink the form of how they do their law enforcement of money laundering or of prevention of crime. And as I said, so of course then the regulators have to acquire a completely new set of skills, because effectively they need to understand how these smart contracts work if they want to do anything about it. But these change at a very rapid pace. Uniswap version 2 is different from Uniswap version 3, and so you need to wrap your head around that. So that's a really hard problem. Now, what lies ahead? What other developments are there? Clearly, let me go first of all show you this picture here, because I think this is quite telling. These are, I think they're about the 20 countries with the largest inflation in the world. You have Venezuela with about 10,000% inflation a year, but then you have Argentina with 47%, Iran with 22%, and so on and so forth. And I think you can make a case to say these countries have, money that is probably worth less than the paper that it's printed on. Right? And it's very painful when you live in these high inflation countries. However, what these countries also have is they have a reasonably high degree of smartphone penetration, meaning that people have the ability to use their smartphone. And what that means is that when they have a smartphone, then they can access the internet, and then with that they can access the blockchain network. So in other words, these people in these countries, this is data from 2018, this is collectively an amount of about 850 million cell phones that exist, or smartphones that exist. So these are all possible users of a blockchain network, and they will therefore all have access to digital representation of a US dollar. They will have access to financial services. What that could lead to is to a worldwide increase in access to financial services, which we know is a major contributor to the betterment and to the development of people generally speaking. So this is a huge opportunity. Of course, I'm not the, people in the blockchain world are not the only people who have thought about this. Facebook has thought about this too. They saw the opportunity that blockchain technology could lead to the development of a new financial infrastructure. And frankly, for many of the tech firms, our current payments network simply doesn't work. It's too clunky, too slow, and way too expensive. So, Facebook therefore went out and built the Libra Now DM Association, which includes, for instance, Shopify. And they went out and said, we're going to build a new financial infrastructure. And their particular use case and what they put on their website is precisely the remittance market, where they could help people in developing countries to improve their financial well-being. And if you think about it, Facebook is not so much something which relates to the US or Canada or the UK. It actually has a huge worldwide audience of over 2 billion people in India, in Indonesia, Brazil, Mexico, all of these countries. And people in this country would probably welcome the idea of having access to a digital representation of the dollar, the euro, sterling, and so on and so forth. And that will fundamentally change the way how people use money in these countries. And of course, let's not forget, Facebook will also bring a lot of functionality with it. So it's not like they're building an infrastructure and they just say, well, you can exchange these US dollars, that's it. There's going to be tools for online commerce and so on and so forth available. And there's also going to be a link to the blockchain world. Now, central banks and governments, of course, notice this too. And this is a graph which shows you just the extent to which central banks have been undergoing research projects to use digital currencies and to think about ways how they can be part of this transformation too. The biggest one is, of course, China, which has the digital yuan or the DCEP, and is already in a pilot phase, and it will most likely get live very soon. Now, they've been working on this for 8 years or so. They are stead ahead of many of the developing countries. But even for the smaller countries that are, in particular for smaller countries that want to maintain some form of monetary policy, once people have access in this global world to, the stable currencies like the dollar or the euro and the like, or even the yuan, they will most likely have a tendency to use it, first out of convenience and eventually out of necessity. So this is a threat to the monetary sovereignty of these small countries. But it's coming, and it's coming also to Canada. Canada has, well, hopefully, the Bank of Canada has issued a contingency plan. Although I have to say, if the contingency are met, it's probably too late. So I hope we're going to get on with this very soon. And so this is something that's definitely coming over the next few years. Now, lastly, I want to talk to you a little bit about what's happening at UofT. And this is, of course, from a very, very selfish perspective. So we're already offering courses on blockchain, decentralized finance in the commerce program, the MBA program, at the Faculty of Applied Sciences in the ECE department. This is just the ones I know of. I'm sure there's other departments that also offer them. We have a research institute. It's called Ledger Hub. It's been sponsored by Conrad Grant. I am one of the co-founders. The other one is Andreas Veneres from ECE. This is where we kickstarted our activities. We have the FinHub at Rotman, which is a large part is about AI and machine learning, which is really important for the legacy financial institutions, but also has a blockchain focus, which I represent mostly. There's a few people and research groups where people are working on this. We have my aforementioned colleague Andreas Veneres from ECE, who worked on decentralized oracles. So that's the idea of bringing information from out of the blockchain into the blockchain. He works on CBDCs, and he's just a great collaborator in general. There's my own work. I work on decentralized trading, CBDCs, and financial infrastructure. And then, I have my colleague at the computer science department, Fan Long, who has some really genius inventions. He found a way, together with with Andrew Yao, Turing Award winner from MIT, they found a way how you can process blocks not in a serial way, as I showed you in my picture, but in a parallel way. And as you know from parallel computing is extremely powerful to get capacity and speed up computing. And what that does is basically create a blockchain which has enormously higher capacity compared to the Ethereum network. So it's orders of magnitude higher and faster. And they also have a clever economic model which allows them to basically tax people for the usage of space, which is another problem that Ethereum faces. So check out what he does. This is now led to the foundation of another blockchain network, which is called Conflux, and he's doing some really amazing work there. Now, I should say that since I'm talking to the alumni, I want to say this. The Wharton School in the US has received a $30 million grant 2 years back or so to study fintech and particular blockchain and so on. And as far as I remember, they had actually nobody even working on this at the time. So they got $30 million. The Ledger Hub has a funding of $250,000, which is running out. And so if you're interested in sponsoring some of this research and want to get involved with this, we're very happy to have a conversation about this. And now with that, I'm going to end my presentation. If you want to have any information about me, you can find me on Twitter. Here's my email address. All the slides that I use will be put on an online system called slides.com, where you can find them. And of course, all my videos, including all my teaching videos from the last COVID-related fall, are on my YouTube channel. This is not a monetized channel, so there should be no ads for it. And there's also my website. Please feel free to get in touch. And now I'm looking forward to jumping into the Q&A. Thank you.